When a soffit in a residential garage adjacent to living spaces and with bedrooms above is used to house plumbing and a forced air duct is routed into it to prevent freezing, it raises questions about compliance with the National Electrical Code, specifically Section 300.22. This section of the code addresses wiring methods in ducts used for environmental air. The key question is whether introducing a forced air duct into the soffit transforms it into a space subject to the restrictions outlined in 300.22. The answer is yes. By introducing a forced air duct into the soffit, you are now using it to handle environmental air. According to 300.22, electrical wiring systems should not be installed in duct spaces used for environmental air handling except as permitted in 300.22 through F. This means the wiring methods within that soffit are now limited to those specifically allowed by this code section. The following wiring methods are permitted in the soffit. Firstly, type NM cable, in accordance with 334.15 AON. Secondly, type AC cable, in accordance with 333.10. Thirdly, electrical metallic tubing, in accordance with 348. Fourthly, flexible metal conduit in accordance with 349. Fifthly, liquid-tight flexible metal conduit in accordance with 351. Sixthly, rigid metal conduit in accordance with 345. Seventhly, intermediate metal conduit in accordance with 346. Eighthly, electrical non-metallic tubing in accordance with 362. Let's delve into each of these approved wiring methods a bit further. Firstly, consider type NM cable. NM cable, or non-metallic sheath cable, is commonly used in residential wiring. 334.15 AM provides specific guidance on how NM cable can be run and supported. It is crucial to ensure that NM cable is supported and protected from physical damage as required by the code. Next, we have type AC cable, often referred to as armored cable. This wiring method, detailed in 333.10, involves conductors encased in a flexible metallic sheath. AC cable offers a degree of protection against physical damage and is often used in situations where NM cable might be more vulnerable. It is very important to adhere to the installation requirements specified in 333.10 to ensure safe and compliant installation. Then, there is electrical metallic tubing, or EMT, covered in Article 348. EMT is a thin-walled metal conduit that provides a robust protective pathway for electrical conductors. It is a versatile option suitable for both exposed and concealed locations. Installation of EMT involves using appropriate fittings and supports to ensure a secure and continuous raceway. Next, we examine flexible metal conduit, or FMC, which is covered in Article 349. FMC offers flexibility, making it suitable for situations where movement or vibration is a factor. It's often used for connecting equipment or navigating tight spaces. However, it is important to properly secure and support the FMC, as well as use appropriate fittings to maintain its integrity. Then there is liquid-tight flexible metal conduit, or LFMC, covered in Article 351. LFMC is similar to FMC but has a liquid-tight jacket, making it suitable for wet or damp locations. It's often used in outdoor applications or where exposure to liquids is possible. Like FMC, proper support and fittings are critical for a reliable installation. Rigid metal conduit, or RMC, is addressed in Article 345. RMC is a thick-walled metal conduit that provides the highest level of protection for electrical conductors. It is typically used in harsh environments or where significant physical protection is required. RMC requires specialized tools for cutting and threading, and proper installation is essential to maintain its structural integrity and ensure grounding continuity. Intermediate metal conduit, or IMC, is another option detailed in Article 346. IMC is a thinner-walled version of RMC, offering a balance between protection and cost. It is suitable for many of the same applications as RMC but is lighter and easier to work with. The same installation practices apply to IMC as to RMC, including proper threading and support. Finally, there is electrical non-metallic tubing, or ENT, covered in Article 362. ENT is a flexible, non-metallic conduit that is often used in concealed locations such as within walls or ceilings. It is lightweight and easy to install, but it does not provide the same level of physical protection as metal conduits. ENT is typically used in dry locations and must be properly supported and secured. Beyond the permitted wiring methods, it is essential to consider the general installation requirements outlined in the NEC. Firstly, all wiring must be adequately supported to prevent strain on conductors and terminations. Secondly, conductors must be protected from physical damage, whether through the use of conduit sheathing or other protective measures. Thirdly, proper grounding and bonding are essential for electrical safety, reducing the risk of shock and fire hazards. Furthermore, it is important to evaluate any electrical equipment or devices installed within the soffit to ensure their suitability for the environment. If the soffit is subject to moisture or temperature extremes, equipment must be rated accordingly. Enclosures should be selected to provide adequate protection against environmental factors. It is also crucial to avoid using the soffit as a storage space for combustible materials, as this could create a fire hazard. Any lighting fixtures installed in the soffit should be of a type suitable for the intended use and installed in accordance with the NEC requirements. Consider the ambient temperature rating of the fixture, as well as its suitability for damp or wet locations if applicable. The use of the soffit for purposes other than housing, plumbing, and electrical wiring may also be subject to local building codes and regulations. It's important to check with the local authorities to ensure compliance with all applicable requirements. In summary, when a forced air duct is introduced into a garage soffit, the space becomes subject to the wiring restrictions outlined in NEC 300.22. Only specific wiring methods are permitted, and all installations must comply with the general requirements of the NEC. Proper planning, careful installation, and adherence to code requirements are essential for ensuring a safe and compliant electrical system.